attention. Okay, last week we started a bit on chemical bonding. Please recall back, what is the ultimate objective of forming bond? To be stable. Okay, what do you mean by stable in chemistry standpoint? The outer shell fully occupied. Okay, that's why you have to know two important words, duplet and octet. Understand? If you have one shell and you are fully occupied with 2 electrons, that's called duplet. If you have more than one shell and your outer shell is fully occupied with 8 electrons, that's called octet. Understand? Alright? So when the outer shell is fully occupied, that is called stable. And please remember, that is the main purpose of forming bond. Understand? Chemical substance form bond because they wish to be stable. Okay, there are two types of chemical bonding I taught you from last week. The first one called ionic bond. The second one called covalent bond, yeah? Okay, for ionic bond is made by metal adjoining with non-metal. For covalent bond, you have a non-metal adjoining with a non-metal. Okay guys, a quick revision. How to know who is metal, who is non-metal? We will use some knowledge we learned from chapter 4. Okay? So always remember, you can refer to the group to know you are metal or non-metal. If you are placed in group 1 all the way to 13, you are metal. If you are group 14 all the way to 18, you are non-metal. Yeah? So this is something you must know. Okay? Alright, so if you still remember from last week, in ionic bond, what we do, a quick recap here. Ionic bond, they involve transfer of electron. Transfer of electron. Guys, what it means by transfer? Transfer means that there is a donate, there is receive. Okay, you have donate, you have receive, that's called transfer. Okay, guys, normally who's the donor? Metal. Normally the metal would donate the electron. Normally the non-metal would receive the electron. So make sure you know this. And the super important thing we learned before. What is it, guys? When a neutral atom, today you are neutral atom, you are neutral in the first place. When you go and donate the electron, when you are neutral and you donate the electron, you will become a positive ion. When you are neutral and somehow you receive electron, then you will all the way become a negative ion. So far so good? Okay? That's it. Okay guys, what we're going to do now is this. Before we go on with covalent bond, which is our main focus for today, okay, we will use one example to recap what we learned, okay? So you don't need to copy anything, just a very quick recap. Just a very quick recap. Okay, now, eyes on here. Let me give you a sample question. You don't need to copy anything. You just listen to what I'm going to show you, okay? Let's say the question sounds like this. Let's say the question is this. There is a A, there is a B. A is 7,3, B is 16,8. Let's say the question asks us, describe the bond formation. Describe the bond formation between A and B. And the total marks allocated is a whopping 5 marks, let's say. Alright? So how are you going to do this? And guys, if you're in your Form 4, you are taking your midterm exam, very likely they will ask something like this, okay? 4 to 5 marks for sure. So how to do it? Okay, everyone recall back the strategy we learned from last week. What is the strategy? When you want to do any bonding question, first and foremost, you must go to write out your electron arrangement. So let's do it. Let's write our electron arrangement. Our A got 2 numbers. Guys, when you want to write electron arrangement, you should use which number? Big or small? Big number or small number? Small number, right? Because if you want to write electron arrangement, you must know amount of electron. Amount of electron same as amount of proton. Clear? So use a small number 3. A got 3 electron. A is 2.1. Look at the B. B has 8 electron. B is 2.6. So after you write electron arrangement, you can use the electron arrangement to decide the group. You can use the group to decide whether you are metal or non-metal. Come, let's do it. Substance A got one outer electron. It is group 1. Group 1 is metal. Substance B got 6 outer electron, which is group 16. Group 16 is non-metal. Understand? So when you have metal, non-metal, you can decide your bond already. You can decide the bond. Since we have metal, non-metal, you all know you form ionic bond. Yeah? Settle. So after decide the bond, don't forget the most important thing. Please, you must go to predict the formula. You must predict the formula of the compound. So how to predict the formula of the compound? In ionic bond, if you want to predict formula, you must know the charge. In ionic bond, to predict formula, you must know the charge. Now my first question to you, are they given us any charge? No, they don't give us the charge, right? Second question, can we predict the charge? Yes, it's possible. Let's predict the charge. How we predict the charge? We just use a simple common sense here. Our substance A got one outer electron. When you have one outer electron, what is the simplest method to be stable? Donate 1. So when you donate 1 electron, you become positive 1. Okay? Same thing, substance B got 6 outer electron. When you have 6 outer electron, what is the simplest way to be stable? Take or receive 2. So you receive 2, you'll be stable. So when you're receiving electron, you become negative ion. Because you receive 2, 2 negative. Understand? So you already predicted the charge, not memorized, you predict it. And once we know the charge, we can predict the formula by using Form 4, Chapter 3. This fella is A plus, this fella is B2 minus. Form 4, Chapter 3 told us, when the charge is different, what to do? Cross, yeah? So 1 go to the right, 2 come to the left. A got 2 pieces, A2. B got 1 pieces, B1, A2, B. Okay? So after predict formula, go for the most important move. You go to draw the diagram. This diagram called cross and dot diagram. This is the most important thing in this chapter. If you don't know this, it's wasted. Okay, cross and dot diagram. Okay, how to draw cross and dot diagram? Listen, whenever you have A and B, let's say you only have one fella A and one fella B, very simple. You draw A on the left, B on the right, that's it. But whenever you have more than one fella, like you have 2A and 1B, you have more A than a B. The one, when you have one fella more and one fella less, you must remember hamburger rule. Remember this? Okay? When you have more than one, you must remember hamburger rule. You have 2A, you have 1B. B is lesser than A. When B is lesser than A, B will be hamburger by the A. So B will be sandwiched in the middle and then sandwiched by 2A on the side. Yeah? Alright? So 2A and 1B. Come, let's draw it. How you draw? Let's start with A. My substance A got 2. My substance A got 2. So just draw a circle and then put 2 electrons here. 1, 2. Substance A got a charge A plus. So when you got charge, square bracket, charge top right corner. Okay? Do the same thing for here. This A is exactly identical. Draw the same thing here. A circle, put 2 electrons, and put a square bracket, and put a plus on top. Settle. So you settle for the A. Let's draw for the B thingy. So B is what? 2.6 and plus 2. Plus 2, don't bother later. Always focus on 2.6. Focus on original first. 2.6, 2 circle, 1 and 2 circle. Okay, just now when you use cross to represent the electron of A, now for the B you use dot. You try to use different symbol. Are you okay with that? Alright, so the B is what? 2.6. Be careful guys, how you put 6 electron. Many people do this, many people put 6 electron. 1, 2, 3, 4, 5, 6. Don't do that. This is not a good move. 6 electrons should be put in this way. 1, 2, opposite, 3 and 4. Okay, then 5 and 6. I keep that. That's a better one. Okay, next one. Your 6 got plus 2. You receive 2 more. So you receive 1 here, you receive 1 here. The electron you receive, you use different symbol. You use crosses, so you can see from far away, oh, everything is dot, but there are two crosses, so you know that these two crosses you get from other places. Understand? Okay? And then you put a square bracket. What is your charge, by the way? Your charge is 2 minus. Put the charge 2 minus on the top right corner. So far, so good. Okay, huh? That's how you do. Now, listen carefully. Guys, I ask you a simple question. If I submit this as my final answer, as my picture, do you think I will get full mark for this picture? No. Why? Why? Nucleus. Understand? Alright, starting from 2016 and onward, you must draw nucleus. So how to draw nucleus? In the center here, draw one more additional circle. That additional circle is nucleus. Are you okay with that? Before 2016, they are not particular. You don't draw still full mark, but after 2016, they are very particular already. So far, so good? Finish. Okay, now, again guys, let's be realistic. This diagram won't earn you 5 marks for sure. Okay, so if you want to get 5 marks, you must able to do the description. So I said last week, how you do a description, assuming that we are writing a Disney story, isn't it? I said last week, assuming you are writing a Disney story. So Disney story got 3 chapters. Chapter 1, introducing the prince. Chapter 2, introducing the princess. Chapter 3, how the prince and princess are joining together. Okay, 3 chapters only, yeah? Okay, now let's introduce your prince, which is substance A. Yeah? Let's tell everything about the prince or the substance A. Yeah? So, substance A, you call it atom. Atom A has electron arrangement. My substance A has electron arrangement. How much, everyone? 2.1. So when my prince got electron arrangement 2.1, what my prince will do? When my prince will want electron, my prince will donate. Alright? So my prince, my atom A will donate 1 valence electron. You must mention valence. So my prince will donate 1 valence electron. For what? Why the atom A want to donate 1 electron? Because after donate 1 electron, you become stable to achieve stable electron arrangement. So my prince donate electron in order to achieve stable electron arrangement. That's it. So after you donated 1 electron, what happened to the prince? The prince become A+. The prince become A+. So when you got charge, you will become ion. So ion A+ is formed. That's it. So this is the prince story, understand? My prince is 2.1. My prince will donate 1 electron. Why? To be stable. After donate electron, what happened to the prince? The prince become A+. Use the same format, use the same template, introducing the princess, the B. Understand? Same thing, okay, write the same thing. Your atom B, which is the princess, has electron arrangement. My atom B has electron arrangement 2.6 is here. So my princess got 6 outer electron. What my princess will do? Receive. Receive how many? 2 more. So atom B will receive 2 valence electron. The princess will receive 2 valence electron. Why? In order to achieve stable electron arrangement. Okay, to achieve stable electron arrangement. Okay, after the princess receive 2 electrons to be stable, after the princess receive 2 electrons, the princess become B2 minus. So the princess now got charged. When you got charged, the name must have the word ion. Ion B2 minus is formed. Okay? So you already settled prince and princess. Okay, last one. How the prince and princess get together, fall in love together. How to do that? So now, guys, how many A you can see from the picture? 2. How many B you can see? 1. So write this. So you have 2 A+ ion and also 1 B2 minus ion. Okay? All these ions, they attracted to each other, guys. When there is positive and negative, opposite charge attract. This force is called electrostatic force. So 2 ions, they are attracted by electrostatic force. Okay? opposite charge, the force is called electrostatic force. So electrostatic force attract them together, they will go to form ionic bond. Okay, they form ionic bond because we already decided they form ionic bond in the first place, right? Okay, so they join together by ionic bond. When they join together by ionic bond, the final product called ionic compound. So when you join together by ionic bond, your final product called ionic compound. What is the formula for your final product? A2B. So A2B is formed. Okay? So by doing this, you can earn yourself 5 marks. Are you okay with that? It's not hard, but it's damn tedious. It's very tedious, right? So many things. And please, don't try to memorize the answer. That's nonsense. Clear? Don't memorize the answer. It's useless. You go to memorize the answer for A and B. Question asks you X and Y, you can do already. Clear? Okay? Don't memorize, but understand how it works. Okay? So in this case, guys, you cannot be so rushed. You have to be patient. As if you have to do step by step. You'll be fine. So okay? 5 marks, guys. Seriously, if you just be patient, if you do step by step, you don't do careless mistakes, it's very possible all of you can score 5 marks. Very possible. Okay? That's all. And if, like what I said, if your midterm exam covered, your school say that they will cover until chemical bonding, I'm very sure they will ask at least one question like this. At least one. Clear? Alright? 4 to 5 marks, confirm. Okay, that's it. Alright guys, now. So anyone has any question to ask me regarding ionic bond? So far, okay? Ionic bond is clear? Alright? And guys, remember, draw your picture first. Then only write your story. Okay? Always draw the picture first, then only write your story. The sequence cannot go wrong. Okay? So everyone, let's revise on this before we go on and learn something new today. Every time when you have a question regarding bonding, always write the electron arrangement for all the atoms. From the electron arrangement, you can decide their group by using the valence electron. After decided the group, you can use the group to tell you whether they are metal or non-metal. Yeah? After you know they are metal or non-metal, you can decide whether they form ionic or covalent bond. So once you decided what bond they form, you must predict the formula of the compound. Guys, don't assume every time it's 1A and 1B. Can be AB, A2B, AB2, A2B3, all possible one. Clear? Don't memorize. Predict yourself. After that, draw your cross and dot diagram. Okay? After draw your cross and dot diagram, then only you go to write the prince and princess story. You go to write the description. You write the prince and princess Disney story. This one. So these are the steps you should know. So far, okay? Alright, good. Now, so guys, I need you to pay attention for the next 1 hour. For the next 1 hour. For the next 1 hour, I'll teach you a whole new chemical bond. This chapter only got 2 things. One is ionic, settled already. Another one is covalent, which is something we will learn for the next 1 hour. Alright, I'll run through total 3 examples. Hopefully you can get some idea. And guys, disclaimer and a warning. Okay, covalent bond is very technical. It's very technical and you might feel very awkward when you first started. You will be fine. Okay? You just go on with me. Alright? Go until the end of this lesson and you see how it works. Alright, now let's start. So this one I erase. Okay, now. So for today we will focus on here. Covalent bond thingy. Okay? Let's look at covalent bond and let's learn some important words. Come, let's start here. Okay, we are learning the second and the last thing in this particular chapter, which is called covalent bond. Okay guys, again, I hope this is the last time I remind you. No matter ionic or covalent bond, the ultimate objective of forming bond is become stable. Understand? Alright? So they want to be stable. That's it. No matter ionic or covalent bond, the main objective is that you want to be stable in the end. Okay? Come, let's start. Now, I'll go very slow. Number 1. Covalent bond is formed among or formed by a non-metal adjoining with a non-metal. Non-metal adjoining together, you form covalent bond. Same thing guys, like the pattern we learned before. If possible, don't copy first, just listen. I'll give you some time to copy later. Okay, So they form by non-metal, non-metal. Second thing, guys, for covalent bond, what they do with the electrons. What they do with electrons. Okay, recap last week. Ionic bond, what they do with electron? They transfer. Transfer means what? Donate and receive. Okay? Covalent, something new. No donation, no recipient, no. Covalent bond only do this. Covalent bond, they share their electron. So this is something new. Okay? You are not donating your electron, you're not giving your electron to other people, you're not receiving the electron, you're not taking electron from other people, but you share your electron. Understand? And I'll teach you how to do later. Okay, now, I want to teach you some simple rules first. Some simple rules before we go on. How you want to show the sharing electron, I will show you later here. To show the shared electron later, you must have this. To show sharing electrons, you must draw something like this. This thing you learned a bit in your mathematics called stack. Stack, okay? Alright guys, you learned before in mathematics, this thing is set A, this is set B. This common area in between is called A intersect B, isn't it? Alright? So guys, what I'm trying to tell is that I'm not teaching you mathematics today. I just want you all to take some idea. This area that I shaded belongs to the A and belongs to the B. Understand? Anything inside here belongs to A, belongs to the B. So this is the shared area. Anything in between here shared by both of them. Understand? That's what I want you to do. Okay, we will learn in a short while. In covalent bond, you need to share the electron. There are three possibilities. Okay, when they share electron, they must follow a simple principle. Everyone put your eyes on here first. Alright, when you share the electrons, okay, when we share the electron, okay, when the atom go to share the electron, when atoms share the electron, it must be fair and square. It must be fair and square. Guys, what means by fair and square? Fair and square means this, okay? Every atom, okay, each atom, they must go to share the equal amount of electron. They must share the equal amount of electron. Guys, what does it mean? This is you. This is me. So we want to share electron. Let's say I decided to put one electron inside here for sharing. If I contributed one electron for sharing, you will also contribute one for sharing. Understand? I share one, you share one. That's it. Okay, same thing. If today I say I got many electrons. I want to put two electrons inside here to share together. When I contribute two electrons for sharing purpose, you will also contribute two electrons for sharing. Understand? Same thing, last situation and vice versa. Today, if I decided to share 3 of my electrons, if I share 3 with you, you will also return the favor. You will share 3 with me. Understand? It must be fair and square. You cannot say this, okay? I got many electrons. You got very little electron. I share 2, you share 1, or do. Cannot. It must be fair. Here, I share 1, you share 1. I share 2, you share 2. I share 3, you share 3. Here. Okay? So this partnership, this collaboration must be fair and square. Understand? Okay, So this is what you need to do. And you can see something very different already. Previously in ionic bond, as you can see, there is square bracket line. Now don't have square bracket already. Understand? Why? You don't even have charge. You only have charge when you donate your electron or receive your electron. But guys, in covalent bond, we don't do that. What we do? We share. When we share electron, no charge at all. So you can see the diagram for covalent bond is so different from ionic. Understand? Clear? Secondly, previously in ionic bond, you can see there is no intersecting area. They don't need to overlap one. But in covalent, they need to overlap. Why? Overlap stands for sharing. Understand? So you must have overlapping. Okay? So we must, you must draw the overlapping. You must draw the overlapping. Okay? to show the sharing of electron. Okay, if you want to share the electron, you must have this overlapping thingy. Understand? Okay, alright. Now, let's use three examples to run together. I think we start with one. And by the way, let me teach you something here. Okay, let's say this is you and this is me. Okay, we can simplify like this. This is A and this is B. This is A and this is B. This is A and this is B. Let me teach you this. When you share one electron with me, this fella is called single covalent bond. We call it single covalent bond. You share one, I share one, single. When you share two, I share two, you can make a wild guess, double. So this is called double covalent bond. You share two, I share two, ma. So now you share three, I share three, make a guess, what is it? Triple, yeah? So this fellow is a triple covalent bond. Now, you can see covalent bond a bit tricky, right? True or not? So many pattern one, got single, double, and triple. Ionic bond don't have this problem, am I right? Ionic bond, just ionic bond. You don't have so many things. That's why I say covalent bond is very technical. Covalent bond can be a bit confusing. Understand? But no worry, go with me slowly, you'll be fine. Okay, settle. Now, let's use one example for demonstration. First example, you might feel blur, completely normal. Second example will be better. Follow me. Okay? Let me do three examples with you. I'll try to do the first example on the whiteboard. Then we try to do together. Okay? Total 3 examples is needed to make sure that you can understand your covalent bond thingy. Okay? Come on guys, listen and follow me. Okay? I'll make sure you got time to copy later. So please don't worry, don't rush to copy by now. Yeah? The first example is this. First example, you given two fella. The first fella called H11. Second fella is actually called chlorine, A35 and 17. Okay? Come on, follow me. Okay, the question asked me, they say, Martin, can you please describe the bond formation? Let's describe the bond formation between or among H and Cl. Again, as usual, this kind of question, normally 4 to 5 marks. Cannot run away, quite standard. Okay, no worry guys, first and foremost, whenever the question asks about bond, follow back the strategy I gave you last week. Get it? The strategy I told you last week not only applicable for ionic, covalent also can. Here, okay, if you forget, you can check back your notes. Okay, guys, what is the first thing? Write out electron arrangement first. Understand? So the hydrogen got only 1 electron, and the arrangement is 1. That's it. True or not? Nothing. Okay. Chlorine got 17 electron. Chlorine is 287. So far, so good. Okay, guys, now, this is where a lot of people have misconception. Listen carefully. Hydrogen got 1 electron. Hydrogen belongs to any group. Many people say group 1. No, wrong. Hydrogen is the one and only fella in the periodic table that doesn't belong to any group. Listen carefully. Hydrogen do not belongs to any group. So hydrogen got no group at all. Clear? Okay, but next thing, common sense. Hydrogen metal or non-metal? Non-metal. Understand? Clear? So I want you all to know, many people thought, hydrogen got 1 electron, I think it's group 1. Cannot. Group 1 called alkali metal. Hydrogen obviously is not metal. Get it? Hydrogen do not belong to any group. Okay? Alright. But common sense, hydrogen is a non-metal. Okay. Chlorine has 7 outer electron, which is group 17. When you're group 17, you are non-metal. So far, so good. Okay, we have non-metal hydrogen and non-metal chlorine. Non-metal, what we form? Covalent. Non-metal, you form covalent. So when we have non-metal adjoining with non-metal, we're supposed to get covalent bond. Yep, that's what we learned today. Okay, now listen carefully. After we decided the type of bond, what should we do? You can check your notes, guys. After we decided the bond, what we do next? Predict formula. Predict formula. Okay, after we know what bond, you should predict formula. Now, this is very controversial. This is very tricky. Listen carefully. Last week, I taught you guys how to predict formula for ionic furler. If you want to predict formula for ionic furler, what I say, you must know the charge, right? You must know the charge. That's what I taught you last week. Completely okay. But now guys, don't mess up. Today we are not doing ionic, guys. We are doing covalent. We are doing covalent. Covalent have no charge at all. Covalent have no charge at all. Listen. So in order to predict the formula, for covalent substance, if you want to predict the formula for covalent compound, no need to know the charge. Hey, if you don't need to know the charge, how we can predict what? No charge what? How? Follow me. That's right here. This is hydrogen and this is chlorine. You don't need to write the charge. No need. No need to write the charge. But you need to do this thing for me. Listen carefully, guys. You need to do this thing for me. On the top right corner, no need to write the charge. You just need to write a number here. You have to put a number here. The number on top here, you must tell me how many electron which is needed, how many electron you further needed in order to be stable. Okay, you just need to write on top here how much electron you further needed to be stable. Don't be panicked, just go with me. Okay, everyone follow me. Let's start with this further. Hydrogen. Come on, follow me. Hydrogen got how many electron? 1. So when hydrogen got 1 electron at the moment, everyone, I want to hear from you. How much electron you further need to be stable? 7, man? No. 1 more. Why 1 will do? So excited. Okay. 1 will do, okay? 1 will do. Okay? But it's okay, thanks for responding, guys. Okay? 1 will do. Why? Because the first shell, how many electron is needed? 2. For first circle, you only need 2. Then you are stable already. So when you got 1 electron, you just put 1 more lah. So you become 2. You are enough to be stable. Understand? So I heard 7 just now. Why 7 is wrong? Because the first circle no need to be 8. Understand? First circle, 2 is sufficient already. Clear? So you need 1 more here. Understand? Okay, Okay, everyone. Next one here. Chlorine. Chlorine got 7 electron on outside. Chlorine got 7 electron on outside. When you got 7, how many electrons you need to be stable? 1 more. Okay? You need 1 more because chlorine is 2, 8, 7. Chlorine have 3 circles. When you have more than 1 circle, you need to achieve number 8 to be stable. Understand? 8 minus 7, you need 1 more. Understand? Does it make sense? Clear? Alright. So what I'm trying to tell you is this. When you have only 1 shell, you don't need 8. You just need 2. Understand? Okay, now. So far so good? Okay, so the number on top here representing how many electrons you further need to be stable. Understand? Okay, now, what to do here? Do the cross. Okay, 1 and 1 cross is the same. You cross. 1 come here, 1 come here. So when you cross a number, you will get your formula. Your ultimate formula will be this. H got 1. Chemistry 1 no need to write. Cl got 1 no need to write. HCl. Are you okay with that? So what I'm trying to tell and impress you is what? To predict formula for covalent bond is a bit special. To predict formula for covalent bond, you don't need the charge at all. Clear? Okay, now we have successfully predict the formula for your HCl. Okay, now listen carefully. How are you going to draw the cross and dot diagram? Okay, guys, how to draw diagram? Listen, this HCl is what? Covalent thingy. Covalent thingy, what they do? Share electron. When you share electron, what you need to draw? Overlapping. Alright? So guys, we have 1 H and 1 Cl. What you do? You draw a circle which is H. You draw a circle which is Cl. Understand? Alright? 1 H, Overlapping with one CL. Why overlap? Covalent. Covalent need to share electron. Share electron need overlapping. Understand? So guys, one of the problem for students is this. They mess up ionic and covalent. Understand? They're very different, huh? Okay, now, the problem is this. How many electrons they should share? I don't know. I don't know. How many electrons they should share? We don't know. You must try and error. I repeat, how many electrons you should share? We don't know. You should try and error. How you try and error? Always try one first. You see, I assume hydrogen share one. Let's say hydrogen, I use crosses. I assume hydrogen share one. Hydrogen put one inside. When hydrogen share one, chlorine return the favor. Chlorine say, you share one. Okay lah, I follow you. I also share one. Understand? It must be fair and square. Okay, now, how to do the next thing? After you share one electron, the next thing is that you must fill up the outside. Sir, what do you mean by outside? Follow me, Hydrogen got how many electrons? One. So when hydrogen got one electron, and that one electron already put inside here, outside here got any other electron? No more. Okay, now, look at chlorine. Chlorine got how many outer electrons? 7. Chlorine got 7 outer electrons. But how many electrons you put inside here? 1, right? You got 7, but you only contribute 1 for sharing. You have how many left? 6 more. So you have 6 more left here. So 1, 2, 3, 4, 5, and 6. Understand? Alright, now, how to know whether you're doing something correct or wrong? How to know you're doing a good job or not? At the end of the day, after you share one electron, you just need to ask yourself a simple question. You just ask yourself a simple question. Are they happy? Happy means what? Stable. Are they happy? Are they stable? Now, let's see, everyone look at here. Hydrogen now, you tell me. Hydrogen got how many electrons now? 2. Hydrogen got 2. Okay or not? Okay, ma. Hydrogen only got 1 shell. 1 shell got 2 electrons. Is duplet. Stable, what? Fantastic. Come on, look at here. Now, chlorine got how many electrons? 8, right? Chlorine now got 8 electrons, right? 2, 4, 6, and 2 more they share. 8. Chlorine got 8. 8 is stable or not? Yeah, ma. 8 is a good number. Octet, right? That's it. So they are stable already. Understand? Simple as that. You're not done yet, If you submit this, you are not getting full mark. You will get a mark, but not full mark. Why? Something left, Number 1. What else went missing? Nucleus. Nucleus. Hydrogen got nucleus, a small circle thingy here. Chlorine got 1 nucleus, a small thingy here. Understand? Guys, you're not done yet. Focus, focus. Listen carefully, Hydrogen got 1 electron, so 1 circle. That's fantastic. But chlorine is 287. Chlorine is 287. How many circles supposedly? 3, right? You suppose there are 3 circles. But how many you have? Only 1, what? Cannot. You only draw the 7 thingy, ma. So the inside you haven't drawn yet. Clear? So inside here, you should draw 2 more circles. Here, you draw 1 more circle, which is the 2 thingy. Another 1 more circle is here. 1, 2, 3, 4, 5, 6, 7, 8. So you draw the 2 here, you draw the 8 here. Understand? That's it. Not very hard. So how's everything covalent bond? Make sense, That's how it works, okay? Alright, so now we have successfully drawn the picture. Okay. After draw the picture, now what you do, guys? Write the prince and princess story, okay? Guys, again, guys, please be realistic. This diagram, this stupid diagram won't earn you 5 marks. No way. No way a picture give you 5 marks. You want 5 marks apart from giving the picture, you must write some description. Come, how you write description? Remember, prince, princess, join together. Prince, introduce your prince. This fella. Okay, my prince is called atom H. My atom H, my prince has electron arrangement. My prince has electron arrangement 1. So when my prince has electron arrangement 1, how many electrons my prince needed? Don't write donate, don't write receive. My prince will need 1 more. Okay? So atom H will actually need 1 valence electron. My prince need 1 valence electron for what? To achieve stable electron arrangement. Okay, my prince need 1 more electron to achieve stable electron arrangement. That's all. Finish the prince. So can we introduce our princess, our chlorine? Yep. My princess is atom chlorine, Cl. My atom chlorine has electron arrangement. So my princess, the electron arrangement is how many? You read yourself. 287, yeah? 287. When my princess got electron arrangement 287, so what? What my princess need? 7 need 1. Learn the word need. I don't want to see the word donate. I don't want to see the word receive. Understand? I want to see the word need. Okay? So my princess, which is the chlorine, it need 1 more valence electron. My princess need 1 more valence electron for what? In order to achieve stable electron arrangement. That's it. Okay, that's all. So after my princess need 1 stable electron arrangement, that's all. Okay, settle. So you have completed your prince and princess. And you don't need to write this, guys. You don't need to write H plus ion is formed. Cl ion is formed. No such thing. Because in covalent bond, you never ever see ion 1. Okay? Alright guys, introducing the prince, introducing the princess. Now the important thing, how the prince and princess, they overlap together. How they join together to form covalent bond thingy. Okay, learn this, learn this. Okay, how many H you have C there? 1. How many chlorine you have there? 1, Learn this, guys. This is important. I think we use red color. Yeah? 1. Okay, hydrogen atom will go to share 1 valence electron. The hydrogen will share 1 valence electron. Share with who? Share with 1 of the chlorine atom. Understand? Alright? I am hydrogen, I have 1 of it. I will share 1 electron with 1 whole chlorine. Understand? So after I share the electron, I know I form covalent bond. Guys, what is this covalent bond? You answer me. Single, double, or triple? Single. How many single bond? 1. So 1 single covalent bond. 1 single covalent bond is formed. Okay? So you have formed 1 single covalent bond. Fantastic. After you already form single bond, this whole fella formed by single bond, this fella called covalent compound. So in the end, covalent compound. So what is the formula for this entire compound? Come on, HCl. So the covalent compound HCl is formed. You got me? Alright? By doing this, you just earn yourself a 5 marks. Not very hard. It's really doable, step by step. Are you okay with that? Guys, don't memorize the whole thing. Make it as a story. Okay? Atom H got electron arrangement 1. So what? I need 1 electron to be stable. Chlorine have electron arrangement 287. So what? I need 1 electron to be stable. When you need 1, I need 1, what they do? They share their electron. So the hydrogen atom share how many? 1 electron. Share with who? 1 chlorine. So after I share the electron with you, what bond I form? Single covalent bond. Yeah? That's it. What is the final formula? HCl. Okay? That's how you do. Not very hard one. Okay? If you understand the logic, most of you will have a very good chance to score 4 to 5 marks. It's not very hard. You just don't rush and you don't be careless. You'll be fine, okay? Step by step, do slow. You'll be fine. Come on, jot down on this. 2 more examples coming up. But I hope you have a good head start on this. Not very hard, yeah? Okay? Come on, jot down on this. 2 more examples coming up in a short while. Alright guys, we will do a second example. We have 3 examples to cover, yeah? So this is first example. Hopefully you can get some idea from here. Okay? So let's go for second one. I believe the second example will be better. Okay? Now, let's do the second one, yeah? Okay, the second example we need to know is this. Okay, let me give you a second example. Okay, now I don't want the whole thing to be so obvious. I don't want H and Cl now. I put some unknown. Let's say we have a further called W, we have a further called Z. Okay? So come, let's do this together. W has a formula of 12 and 6. Z has a formula of 19 and 9. Let's try this. Okay, same thing, the question asking me to describe the bond. Now we want to describe the bond formation between or among W and Z. As usual, we will be awarded with 5 marks. Okay guys, come, same thing. So let's follow the flow, the steps. Step number 1, write electron arrangement. W has 6 proton, therefore 6 electron. 6 electron is 2.4. W got 4 outer electron that put it in group 14. Group 14 is a non-metal. Yeah? Same thing for the Z. Substance Z got 9 electron and hence is 2.7. 7 outer electron put the Z in group 17. Group 17, it is a non-metal. So now we know already W is a non-metal, Z is a non-metal. You all know you will form covalent. Yeah? Non-metal plus non-metal, you will form covalent bond. Yeah? Okay, we already know what bond they form. Now we should always predict the formula. Guys, allow me to remind you one more time. Predicting formula of ionic and covalent is very different. Okay? For ionic, you must know the charge. Then only you can predict the formula. Understand? For covalent, no need. So for covalent, what you should do? Write the formula W, write the formula Z. On the top right corner, you write down the amount of electron you needed to be stable. Okay, how to know how much electron you need to be stable? Let's go through the electrons here. W got 4 outer electron. When you got 4 outer electron, you need 4 more to be stable. Understand? Because W got 2 shells. When you have more than 1 shells, the number you're chasing after is what? 8, right? So you are chasing for 8, you have 4. 8 minus 4, you need 4 further. Understand? Same thing. Z. Z also got 2 shells. When you have more than 1 shell, we are looking upon 8. You want 8 to be stable, you have 7 already, you further need 1 more. Understand? Now exchange the number please. 4 crosses to the right, 1 cross over to the left. W got 1 piece, W, 1 no need to be written in chemistry. Z got 4 pieces, Z4. So the formula is WZ4. So far so good? Okay, now we already know the formula is WZ4. Now the question is what? How to draw. Yeah? So remember what we are doing now. Covalent bond. Covalent bond, you expect what you want to draw. Overlapping, right? You must have overlapping. Okay guys, same thing we learned before. If you have 1 H and 1 Cl, simple lah, side by side. But now you have 1 W and 4 Z. Your Z is much more than W. When you have 1 furler, much more than another furler, hamburger rule. Okay? W is lesser. W will be the middle. Understand? And sandwich or hamburger by Z. Now, let's do it. Let's do it. Okay, so we should put the W in the right middle. W in the right middle. W will hamburger by 4Z. So how to put 4Z? 1Z over the left, 1Z over the right, 1Z on the top, 1Z at the bottom. Okay? That's it. 1 left, 1 right, 1 top, 1 bottom. That's how you put 4Z together, yeah? Alright, now, same thing. When you come to covalent bond, you must draw this overlapping thingy. Are you hear that? Remember guys, in covalent bond, what you do with electron? You share, right? You share the electron. And I told you before, how many electrons you share? We don't know. You must try and error. Let's try. Assume we share 1 electron first. Let's assume we share 1 electron. Okay, let's say W share one electron with the Z. Z return the favor. Z also share one. W share one electron with the Z. Z also share one with W. W share one electron to the Z. Z share one more electron to W. Same thing here. W share one electron with the Z. Z share one with W. Understand? Remember, sharing electron must be fair and square. You share how much? I share how much. Understand? Okay, after that, what do you do? Draw the outer electron. Come on, let's draw the outer electron. Let's start from Z. Z got 7 outer electron. Z supposed to have 7 outer electron. Everyone, how much electron Z shared? 1. Z only used 1 out of 7, yeah? So you have 6 more outside. So 1, 2, 3, 4, 5, 6. Understand? Do it the same for all the Z. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Don't forget your W. W got how many outer electron? 4. W got 4 and you utilize 1, 2, 3, 4. You got 4 and you use all the 4 for sharing purpose. So nothing left outside. Clear? Okay, how on earth to know that whether we are doing something good or bad? Ask ourselves a simple question, are they happy? Happy means stable. Look at your Z. Z currently got 2, 4, 6, 8. 8 is a good number. Octet, right? Look at your W. 2, 4, 6, 8. That is a good number. Stable. Understand? Now Z is stable, W is stable, everyone is happy. So this is what we want. Clear? And don't forget, you have to draw nucleus. Come on. Draw nucleus first. Small circle nucleus, small circle nucleus, small circle nucleus, small circle nucleus, small circle nucleus. You're not done yet. Don't forget all the shell here, they have inner shell, they have inner circle. W is 2.4. W should have 2 circles. You only draw the outer one. You should have one more inner circle, which is the 2. Understand? Alright? Same thing. Z is 2.7. You only draw the 7 outside thingy. You didn't draw the 2. Draw one more circle inside. That is your 2. Draw one more circle inside. That's your 2. Draw one more circle. That's your 2. Draw one more circle. That's your 2. Guys, just imagine how you memorize this. Understand? So many circles. How to memorize? It's very hard. Clear? So you better know how it works. So far so good? You know how this picture coming from? So again, if you try to memorize the picture, of course it's damn hard. But if you understand how it works, it's okay one. Clear? Good. Settled. Now, after you do this thing, let's go to write the story. Let's write your description. How you write your description again? 3 parts. Prince, princess. Okay? So start with the first fella. W, W my prince. Atom, W my prince, has electron arrangement. So my prince, the atom W has electron arrangement. How many? 2.4. Yeah? So when my prince got 2.4, what happened? My prince actually, learn the word need. My prince need how much? 4. You need 4 more. My prince need 4 valence electron. You need the 4 electron for what? In order to achieve stable electron arrangement, yeah? So you need 4 electrons to achieve stable electron arrangement. Okay, end of story. That's all for the W. Do the same thing for Z, okay? So atom Z. Atom Z, meanwhile, has the electron arrangement. So what is the electron arrangement for Z, everyone? Read yourself. 2.7, 2.7. So when you have 7 outer electron, you need 1 more. So atom Z eventually need 1 more valence electron in order to achieve stable electron arrangement. You need 1 more electron with the purpose to achieve stable electron arrangement. Okay, everything looks good. So now you have finished to talk about the prince and princess. So now the most important thing, how they are joining together. So guys, how they are joining together? This is covalent bond. Covalent bond, most importantly, what they do? They share electron, right? Okay, guys, how to know how much they share? Don't trust all the answer here. Look at the picture, guys. What you saw? W, how many W? 1. So 1 atom W go to share. W share how many electron here? 1, 2, 3, and 4, right? W contributing 4. So W contributing 4 valence electron. You must mention valence, okay? Don't only write electron, must mention valence. 1 atom W share 4 of its electron with who? Z. How many Z in here? 4, okay? With 4 of the atom Z. Understand? Make sense, right? 1 atom W share 4 electron with 4 atom Z. Okay, now when you come to covalent bond, it's a must for you to specify single, double, or triple, right? Come on. 1.1 cross single, 1.1 cross single, 1.1 cross single, 1.1 cross single. You have 4 singles. Okay? So 4 single covalent bonds. 4 single covalent bonds are formed. So when you form 4 single covalent bonds, at the end of the day, who you are, the whole thing is WZ4. This entire fella is merged together by covalent bond. So this entire fella called covalent compound. Understand? So at the end of the day, covalent compound WZ4 is formed. I hope the second example gives you a better idea of what is happening. Did you see a format? What we are doing? Alright? We follow a very standardized method. Your job is that don't be lazy, don't do shortcut, follow closely. You will be fine. Yeah. Because they always follow a format one. You go on the format, you'll be fine. Okay? So jot down this, we left one last example, then finish. Okay? We have one more last example. So guys, I hope you realize that covalent bond not as hard as you thought. It's okay, it's doable. It's doable. So in a short while, we will run through the last example together, then we finish. Okay?
Surprise! Wait, one more. One. Anyone?
Alright guys, give me another 5 to 10 more minutes. Let me finish off the last example for today. Yeah? Okay, let's do example number 3. I just modified a bit, will do. This is example number 3. Let's say this fella, I put it become a C. This fella, I put it become a D. I change the number. This is 16 and this is 8. Alright, I want to describe the bond formation among C and D. Okay? The rest is absolutely the same. Yeah, come. Let's do this and let's get it done. Okay, let's erase everything and we start from scratch. Yeah? Okay, same thing. Whenever we have any bond related questions, whenever you have any bond related question, always begins with writing electron arrangement. Substance C has 6 electrons, which is 2.4. 4 outer electron is group 14, which put it as a non-metal. Substance donkey has 8 electrons. 8 electron is 2.6. 6 outer electron make it become group 16. Group 16 is a non-metal. So far so good? So we have non-metal C and non-metal D joining together. They will go by covalent bond. So far so good? Okay? Now, as usual guys, after we know what bond, we must predict formula. Okay, come on. Let's predict formula. Predicting formula for covalent, no need the charge. So you only need to write the C and D. On the top right corner, write down the amount of electron you need to be stable. C got 4 electrons, so you are looking for 8, you need 4 more. D got 6 electrons, you're looking for 8, you need 2 more. Yeah? Exchange the number, 4 goes over to the right, 2 comes over to the left. So technically, your formula supposed to get C2 and D4. You don't finish yet. C2 and D4. My question, can the 2 and 4 be further simplified? Yes. So you should simplify it. Whenever the number could be simplified, you must simplify. 2 and 4 both divided by 2, you get 1 and 2. So at the end of the day, you get C1, D2, CD2. Understand? Alright, hamburger, okay? 1C and 2D, hamburger. So C is in the middle, hamburger by 2D on the side. Very good, okay? So same thing, we need to share electron. We never know how much electron to be shared. Let's try share 1 first. So if the D contributing 1 electron for sharing, the C will also contribute 1. If the D contribute 1, the C will contribute 1. Okay, how to know whether we do something right or not? Let's try to fill out the outer electron, yeah? Okay, our substance C got 4 electron. Our substance C got 4 electron. You got 4 electron, but you use 1 here and 1 here. You only contributing 2 electron for sharing, but you got 4 So which means that outside here you have 2 more. Am I right? Same thing. Look, what about the donkey? Donkey got 6 electron, but for donkey you only contributing 1 electron for sharing. You only use 1 out of 6 electron. You left with 5. So 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Okay, after you share the electron, always ask yourself, are they stable or happy? Okay guys, now let's check 1 by 1. Let's look at the donkey here. How many electrons you have? 2, 4, 6, 7. 7, happy or not?
No.
Not happy, right? Okay, now look at the C. C got 2, 4, 6. Happy or not? No. Understand? So what happened here? It means what? After they share 1 electron, the D is not stable, the C is not stable, which means what? Sharing 1 electron is not enough. Understand? Now only you share 2. Clear? That's why it's all about try and error. You never know how much you should share 1. You should try and error. You try to share 1 and you ask yourself, are they happy? Happy? Okay lah. If after share 1 they're not happy, what to do? Share 2. Clear? So now let's redo again. Now let's share 2. Now the donkey will throw 1 more electron inside. So donkey share 2. So when donkey share 2, the C will also share 2. C will dump 1 more inside here. Understand? Do the same thing over here. The donkey share 1 more. This electron throw inside. Now the donkey will share 2. When donkey share 2, C need to do the same thing. C also throw it in to share 2. Understand? Now you ask yourself that question again. Are they stable? 2, 4, 6, 8. That's good. 2, 4, 6, 8. That's good. Clear. And that's what we want. Understand? It's all about try and error. Understand? Wow, sir, I try and error, I should try it tomorrow. No worry, your maximum only 3. You share 1 cannot, then 2, 2 cannot, 3, 3 cannot. Question got problem. Clear? Alright? Maximum you share until 3. You got me? Alright, now, you're not done yet. Don't forget to draw nucleus. In the center, you have nucleus, nucleus, and nucleus. So far so good?
Yes.
Okay, now, look at the C. C got 2.4. 2.4, you have 1 more circle for the 2. So you draw 1 more smaller circle for the 2 here. Your donkey is 2.6. You have 2 electrons inside. Draw a small circle, 2 electrons inside, and 2 electrons inside. And that's it. Okay, so that's how the whole thing works. I don't say easy, but I don't think very hard. Okay? It's really doable. You must understand the logic step by step. Come on, let's write the story. Come, let's do it. Atom C has electron arrangement 2.4. C is 2.4. Same thing, atom C is 2.4. So when it's 2.4, atom C further need 4 more outer electron to to achieve stable electron arrangement. Okay, settle. Now, second fellow is atom donkey. Atom D, the electron arrangement, as we can see, 2.6. So 2.6, so when you have 6 outer electron, your atom D need 2 more. So they need 2 more valence electrons in order to be stable. Okay, so you already introduces the prince and princess, C and D. Now, how they join together? Watch out your diagram. How many C you have? 1. So 1 atom C will share how many electrons? The C here, 2 here, 2, 4. So 1 atom C share 4 valence electron. You share among 2D. You share with 2 atom donkey. Understand? Alright? So now what you form, guys? 2 dot, 2 crosses. This is a double bond. This is a double bond. You have 2 double bonds. Yeah? Okay. So you form 2 double covalent bonds. So you form 2 double covalent bonds in the end. So after you form covalent bond, this whole thingy is covalent compound. Your final formula is CD2. So your final formula CD2 is formed. Alright? And that's it. You got me? Finish chapter 5. You get the idea? Not very hard, right? Doable. It's really doable. If you really understand the concepts, you will be fine. You will be fine, okay? It's not really hard. Most importantly is that when you get a question, you must know the logic, right? Step by step. Number 1, writing electron arrangement. By using electron arrangement, decide the groups. From the group, decide they are metal or non-metal. Once you know you are metal, non-metal, decide ionic or covalent bond. Yeah? After you know what bond you need, predict the formula. Watch out, watch out. Ionic compound need to know the charge. Covalent compound, no need to know the charge. Okay? So make sure all of you know how to predict formula for ionic, how to predict formula for covalent. That is very important. After predicted the formula, draw the cross and dot diagram. Understand? After draw the cross and dot diagram, write your description. Prince, princess, join together. That's it. Okay? Not very hard. Alright, so I think that's it. You can jot down on this and we'll finish with your covalent bond. Okay?